Okay, good morning. Today we will start Fourier analysis. Okay. Now I am sharing the PPT. Have you heard and have you studied regarding Fourier analysis or Fourier transform in your first year?
Yes, sir. Yes, ma'am. If a function can be written in part of sine and cos.
Okay, repeat Arjun.
A function can be written in form of sine and cos.
That is called Fourier series.
Yes, ma'am.
Is there any restriction? Any function can be expanded in
No,
Fourier
ma'am. No,
series?
ma'am. Periodic function. Um, the function should be periodic.
After that,
The integrations should exist. A
okay,
n, b n.
now let me start what
Yes,
is
ma'am. Yes,
Fourier
ma'am.
series and Fourier transform. So today our presentation is on Fourier method of waveform analysis. Okay, so what we will try to cover today: introduction, concepts of Fourier series, definition of Fourier series, harmonics, Dirichlet's conditions. Have you heard the name Dirichlet's conditions?
Yes, ma'am.
Evaluation of Fourier coefficients, and after evaluating the Fourier coefficients, how to evaluate it, that is A0, A and B, and you will be able to get a Fourier series. Okay. Now, what is the introduction? In 1807, the French mathematician Joseph Fourier submitted a paper to the Academy of Sciences in Paris containing mathematical description of problems involving heat conduction. Now, how can you get the name Fourier? Okay, well, basically the name is on the base of a mathematician Joseph Fourier. Although the paper was at first rejected, it contained ideas that would develop into an important area of mathematics, named in honor Fourier analysis. The idea today is important in modeling many phenomena in physics and engineering, right? So, on the basis of name of mathematician Joseph Fourier, the name is Fourier transform or Fourier analysis on honor of that physician, I mean mathematician. Uh, Now, concepts of Fourier series. Already Arjun has told that, ma'am, it will be applicable in periodic functions, right? So, we will apply the concept of Fourier series to find the steady state response of an electric circuit subject to a periodic excitation. An electric circuit will be excited with a periodic excitation. So, what is your idea regarding periodic? Just give an example.
F of t equal to f of t plus capital T.
No,
The
no,
capital
just an example.
sine function is a
Sine
periodic
function,
function.
cosine function,
Sine omega t.
periodic in nature, right? It will be repeated after a
Yes.
certain time interval.
Cos
That is
function.
periodic. Yes. So a function time ft is said to be periodic in general way if ft equals to f of t plus minus nt, right? That is a repetitive function where n is a positive integer and t is the period. Thus, a periodic function repeats itself every t seconds. So this is a periodic function. This is periodic triangular wave. And at the point A, you are getting the maximum amplitude. Again, at the point 3A, you are getting maximum amplitude. And after, where you will get maximum amplitude again?
5a.
5. Right. A, 3A, 5A, that is odd multiple. And this is another sawtooth wave periodic function 0, pi, 2 pi. And at the point pi, you are getting maximum value. At the point 3 pi. So at the point, which one you will get the maximum in this situation?
5 pi. All
5.
odd functions of 5.
Right. So these are all the periodic functions because at a certain time interval, the function will be repeated, right? Now come to definition of Fourier series. A Fourier series is a way of representing a periodic function as a possibly infinite, right? sum of sine and cosine function. Arjun has told in the previously that ma'am, it is a combination of sine and cosine function and it is applicable in periodic functions. So Fourier series is a way of representing a periodic function as a sum of sine and cosine functions. Thus, if ft is a periodic function, then the Fourier series is like this. Ft that equals to a0, a1 cos omega t, a2 cos 2 omega t, up to n cos n omega t. This is the cos part. Now come to sine part. b1 sine omega t plus b2 sine 2 omega t, ultimately plus bn sine n omega t. So this is the series containing cos term and the sine term, right? So this is equals to a0, n equals to 1 to infinite, n cos n omega t plus bn sin n omega t. From this term, you are writing n cos n omega t. From this term, you are writing bn sin n omega t. So where omega is the fundamental frequency, everybody knows omega equal to 2 pi by t, and n omega is the nth harmonic of fundamental frequency. This is. So this n omega, just I want to say, and this omega is the fundamental frequency. And harmonic of fundamental, that is n omega, multiple of that. And a0, an, bn are the Fourier coefficients. So if you want to get the Fourier series of any particular function, you have to determine the value a0, an, bn. Now you have to know how can you determine a0, an, bn. Now you can ask me, ma'am, what is harmonics? Just in this slide, what I have told you, n omega is the harmonic of fundamental frequency. So if it is omega, the basic frequency, then the harmonics will be what?
2 omega, 3 omega, 4
Yes.
omega.
Okay, come to this slide. Harmonics are currents or voltages with frequencies that are integer multiples of fundamental frequency. Right? If the fundamental
Yes,
frequency is 60 hertz, then second harmonic will be 60 into 2, that is 120 hertz. The third harmonic will be 180, that is 60 into 3, etc. So harmonics are, that is the multiple of fundamental. If fundamental is 60 hertz, the second harmonic will be 60 into 2. The third harmonic will be 60 into 3, like this. Now I have told the Fourier series, if you want to generate, then you have to obey the Dirichlet's condition. Then what are the Dirichlet's conditions? Do you remember any condition? Do you remember?
no, ma'am. Orbit.
Chalo, the conditions under which a periodic function ft can be expanded in a convergent Fourier series are known as Dirichlet's conditions. So what are the conditions are here? Ft is a single valued function, number one. Number two, Ft has a finite number of discontinuities in each period t. Ft has a finite number of maxima and minima in each period t. The integral 0 to infinity mod of ft dt exists and is finite, or in other way, ft mod ft whole square dt third integration that will be less than infinite. Basically, all these conditions, when you will go through an example, then you will understand what are the conditions you have to maintain in case of Fourier series. Okay. Now come to PDF. Fourier analysis. Okay. Why is not visible? Is it visible, Fourier analysis?
Yes, ma'am.
Yes, ma'am.
Yes,
But
ma'am.
at that time the slide was not visible. I don't know why. Okay, this involves two operations: the evaluation of the coefficients a0, an, bn, truncation of the infinite series after a finite number of terms, so that ft is represented within allowable error. Now come to how to evaluate Fourier coefficients. Okay, how to evaluate Fourier coefficients? What are the coefficients? Shrestha, coefficient gulo ki ki?
Ma'am, A0, uh,
An, Bn, and A0.
N.
Okay, so Fourier method of waveform analysis. Come to this PDF. Is it visible to all of you?
Yes, ma'am.
Now, how to evaluate the Fourier coefficients? The evaluation of Fourier coefficients An and Bn is accomplished by using simple integral equations. Mone porche? How can you get the An? Do you remember? I think you have studied in your mathematics. How can you determine An?
By the integration of sine and the function.
What is the mathematical expression of that? I think
Integration
you
minus
remember.
t to t sine omega t into ft, I think. I'm not
Okay.
sure.
Okay. The evaluation of Fourier coefficients An and Bn is accomplished by using simple integral equations, which may be derived from the orthogonality property of the set of functions involved, namely cos n omega t and sin n omega t with integer values of m and n. These functions are orthogonal over a time period capital T. Orthogonal means perpendicular. First, observe that sin m omega t equals to 0 for all m. How can you get it? What is the, if you solve this, what is the integration of sin m omega t? What is the, Devashish, what is the integration of sin m omega t?
Minus cos
Right? By m omega.
M omega.
Okay. Now, if you put the, limit 0 to t, then what will be the value?
0.
How? How can you get 0?
Sine 0 is 0.
No. You have told the answer is minus cos m omega t divided by m omega.
Oh, sorry.
Right?
Cos.
Initially, first you have to put the maximum limit.
Okay.
What is this?
Yeah.
What is this? Sine cos m omega t.
Minus of cos m omega t by m omega.
Yes. Then I have to wait.
Minus plus.
I'm showing you. Okay, just wait. It's very simple. A simple integration now.
Yes, ma'am.
What was the part?
Sin m omega t 0 to t.
It was 0 to t, right?
Yes, ma'am.
0 to t. Sin
m omega t.
M omega t. Okay. Now, what is the integration of this one?
Minus cos m omega t by m omega.
Minus 1 by m omega. Right?
Yes, ma'am.
ওটা একটা ডিটি হবে না?
হ্যাঁ নিশ্চয়ই হবে cos তা না হলে তো ইন্টিগ্রেশনই হবে না, রাইট? I have missed it. Cos omega t. Just you are telling me here, right?
Yes, ma'am.
Definitely it will be. So limit is what, Arjun?
Capital T 0.
0 to t.
Yes, ma'am.
Then what is the value?
Minus 1 by m omega cos m omega capital T.
Yes. You can write it plus, provided limit will be 0 to t, right?
Yes, ma'am.
So cos 0 means 1.
Yes, ma'am.
Right. Now it will be minus of t. So
yes.
t equal to what? T equal to what?
capital T.
Equal to what? Hey, Bolo, what is capital T? What is the value of that?
2 pi by omega.
Right, 2 pi by omega. Then
Omega cancelled out.
Right. What is cos 2 pi? Same equals to 1. What is cos 2 pi?
1.
Then what is the value of that? 1 minus
0.
1? That will give 0.
Yes,
And this way you are getting integration of 0 to t sin m omega t dt, that is equal to 0. That I have written over here. For all m, maybe odd or even, right?
Yes, ma'am.
Now come to again 0 to capital T cos n omega t, that is equal to 0. How can you get it?
Cos means the integration will be sin n
Provide.
omega t by n omega.
Arjun, repeat.
Integration হবে হচ্ছে কি sin n omega t by n omega
Right.
into 0. Then sin n omega capital T minus sin 0 is 0. That part cancel out. Now capital T equal to 2 pi by omega. So sin 2 pi by omega into omega means sin 2 pi. Sin n 2 pi and
N
that
2
is
pi
0.
minus sin 0, 0. Okay.
Yes, ma'am.
Then what is the value of sin n 2 pi?
0.
0. Hence you are getting 0.
Yes,
Okay,
ma'am.
clear to all of you. Since the average value of basically a term when will occur, you have to put 0. Hence, at the initial stage, you have to remember how can you get this equals to 0. Since the average value of a sinusoid over m and or n of complete cycle in the period capital T is 0, obviously. The three cross product terms are also 0 for the stated orthogonal relationship of n and n. Again, therefore, sin m omega t cos n omega t dt, that is equal to 0. 0 to t. Can you prove this one?
Yes, ma'am. একটা cos রাখতে হবে, বাকি cosটা মানে cos n minus 1 omega t টাকে আলাদা করতে হবে, আরেকটা cos n omega cos omega t হবে।
কি বলছো? আমি তো এটা sin 2 থিটা করতে পারি কি পারি না?
হ্যাঁ, সেটাও করতে পারি। হ্যাঁ, এটা তো ইজি সাইন, হ্যাঁ, ওইভাবে করলেও হয়ে যাবে।
That will be easier, right now?
Yes,
half into 2, the sine of this, that is sin 2m omega t, right? And you have to do the integration of that. Ultimately, you will get this one, right now? Automatically, it will be 0. Again, sin m omega t, sin n omega t. Again, it will be 0. And condition is that m not equal to n. Mainly. After that, cos m omega t, cos n omega t, that is equal to 0. M not equal to n. How can you do it? Anybody else except Arjun, how can you do it? Cos m omega t, cos n omega t, that is equal to 0. But m not equal to omega. And cos square m omega t or cos square n omega t, not like that. How can you do it? Cos a cos b, there is any formula?
Yes, ma'am.
Pritam, are you there? Pritam, achish? Pritam, present or absent?
Achi, ma'am.
Pritam, ball. How can you get the value equal to 0? Explain.
Wait, ma'am. Done, ma'am. Formulaটা ম্যাম মনে করছি, এটা ইয়ে করতে হবে একটু।
What to do? Okay, just you remember and then tell me, okay? The integrals become non-zero when n and m are equal. Sin square m omega t dt, that is equal to t by t. And how can you get it capital T by 2? Already I have written over here sin square theta, that is 1 minus cos 2 theta by 2, right now?
Yes, ma'am.
So you can, I mean, write this term in terms of this, and after that take the integration of that, you will be able to get that is equal to capital T by 2 for all m, might be odd or even.
Yes, ma'am.
Pritam, did you remember? Everybody will do this one. How can you get cos omega t and cos n omega t, and then you will tell me, okay?
ম্যাম 2 cos এ তো cos b তে করবো 1/2 কমন নিয়ে, তারপর ম্যাম cos a cos b ফর্মেট হচ্ছে cos a plus b plus of cos of a minus b, ওরভাবে করে দেবো cos omega t।
Pritham, clearly bolo. What you will do? Just tell me the formula clearly.
ম্যাম ফার্স্টে ম্যাম 1/2 কমন 1/2 into 2 of
2 cos A cos B. Basically, you are getting 2 cos A cos B. What is the formula?
ফর্মুলা হচ্ছে ম্যাম cos m plus n into of omega t, তার হচ্ছে প্লাস অফ cos of m minus n into omega t।
Pritham is right or wrong?
বাই 2 করতে হবে।
i2 টা তো বললাম আগে, ওটা
বললো তো বাই 2 করতে হবে।
ওটা আগে বলে দিয়েছি।
এখানে কি রয়েছে 2 cos A sin B and you have to need 2 cos A cos B. What is the formula?
ম্যাম ওই তো সেকেন্ডেরটাই লেখা আছে, পাশেই দেখুন
sin a plus b minus
প্লাস অফ cos of a minus b,
This one. Pritham, এটা বলেছিস তো?
এটাই বলেছি cos of m plus n omega t plus of cos of m minus n into omega
তাহলে
t।
definitely during the analysis of Fourier series or Fourier transform, you have to know different trigonometrical formula, right না? এগুলো তোমাদের একটু রিক্যাপ করতে হবে। all the formulas you have to recap. ঠিক আছে? এটা হয়ে যাচ্ছে, জাস্ট লিখে দিয়েছি বলে হয়ে যাচ্ছে, not like that. You have to do it. How can you do it? So all this the formula. If you put all these things, you will get capital T by 2 or capital T by 2 or 0, whatever. Mute yourself, please. The Fourier coefficients can be evaluated by application of the above relations. A relation will, on the basis of that relation, you have to do, derive the Fourier coefficients. First is that, what is, and the equation, a n cos n omega t plus b n sin n omega t, this is one part of that. And please mute yourself, then unmute also. So this is the one part, that is constant part a0, and this is another part. This another part actually a n cos n omega t, b n sin n omega t. Already I have told you in the previous PPT. Now what is a0? A0 means 1 by t 0 to t ft dt. You have to remember this. Just write down in your copy. When I will do an example, then I will use this formula. What is a0? 1 by t 0 to 2 ft dt. এটা মনে পড়ছে তোমাদের? Do you remember?
হ্যাঁ ম্যাম।
yes ma'am
T equals to 2 pi, the time period. Now in order to evaluate an, what to do? ft equals to this a0 a1 cos omega t up to an cos n omega t plus b1 sin omega t bn sin n omega t. You know all this formula. A0 plus summation of 1 to infinity n cos n omega t plus bn sin n omega t. It is clear. Now you have to determine what an, right now.
yes ma'am
An, how to determine? During the determination of an, what to do? You have to multiply the total function with cos m omega t dt 0 to t. So this total function will be like this, will be multiplied by cos m omega t. So first one is a0, a0 cos m omega t, that is integration of 0 to t. After that an cos n omega t into cos m omega t, right now? And this term is here bn sin n omega t into cos m omega t. Basically you are multiplying cos m omega t with 3 parts, a0 and this part and that part. Now come to here. So cos m omega t dt equals to 0. You know that already, you have seen that. Cos m omega t bn sin n omega t equals to 0. Cos n omega t an cos n omega t equals to 0. And this is equal to capital T by 2. How can you get it? Write this. Just go through this. Have a check. This from all this formula, right? This. Mute for a. Who is unmuted? Please mute yourself. Noise is coming. Now come to here. 0 to t am cos m omega t cos m omega t, that is equal to capital T by 2. It will be n omega t am. Therefore, for an equal to what? 2 by t, 0 to t when n equals to m, ft cos n omega t dt. So ultimately the thing is that what is n? You have to remember this is the an value. An equals to 2 by t, 0 to t, ft cos n omega t dt. Just write down. First ki likhecho? A0 equal to what? After that you write an equals to what? So this is equal to this for all integer values of n. Mind it, integer values of n. Now what to determine? A0 is finished. The determination of an is finished. Now what is left over here? Bn. How can you determine Bn? Anybody else?
Sin m omega t of kota.
So basically you have to multiply the function with sin n omega t. So if you multiply sin m omega t just like the previous one, it will be here sin m omega t, again sin n omega t, again sin m omega t for 3 individual part of the ft. Now again you have to remember sin m omega t, that is equal to 0, this equals to 0, this equals to 0, and this equals to capital T by T Bm. Therefore, for n equals to m, you are getting Bm, that is equal to 2 by t, 0 to t, ft sin n omega t dt. For all integer values of n. So ultimately what you are getting? A0 equal to 1 by t, 0 to t, ft dt. An equals to 2 by t, 0 to t, ft cos n omega t dt. Bn equals to what? 2 by t, 0 to t, ft sin n omega t dt. So after evaluation of A0, An, Bn, this is the basic you have to remember during the analysis of Fourier series of a particular function. Up to this, is it clear to all of you? How can you get A0, An, Bn? Yes?
Yes, ma'am.
Rest of the students, yes or no? Any
Yes,
query? Ki Shubhra Kamal,
হ্যাঁ ম্যাম
did you understand?
ইয়েস ম্যাম আই আন্ডারস্টুড বাট আমি অ্যাকচুয়ালি ফর্মুলাগুলো মানে ট্রিগোনোমেট্রি ভুলে গেছি সো ওগুলো একটু রিভাইজ করতে হবে
Right. Diporna, did you understand how to determine?
Yes, ma'am.
Okay. Krishnendu, Nomajis, you are there? Nikita?
Yes, ma'am. Yes, ma'am. Krishnendu.
Krishnendu, did you understand how can you determine A0, A and Bn?
Yes, ma'am.
Okay. Purvita, তুমি কি লেট জয়েন করেছো আজ? No.
Yes, ma'am. আজ লেট জয়েন করেছি একটু 5-7 মিনিট।
Okay. Did you understand?
Yes, ma'am. Understand.
Okay. ঋষভ কিছু বুঝতে পারছো?
হ্যাঁ ম্যাম।
Rohit, are you there? Rupam, Sarthak, Sayan, Shreya, Soumodip.
হ্যাঁ ম্যাম
Yes,
Okay, chalo, very good.
ম্যাম
So, these are all. Now you want to do a problem or come to another theory waveform symmetry? What is your wish? What do you want?
থিওরি ম্যাম, থিওরি
এটা কে বলছো?
থিওরি ম্যাম।
ইরফান, I
ইরফান,
know you, ইরফান, because problem হলেই তো ইরফানকে করতে হবে না? Irfan, what are you doing? You are sleeping till now or you are listening to me?
No, ma'am. I am in class.
Your class, what I have told up to this class?
Analyzation of a particular function of its Fourier series.
How to determine
the Fourier series of a particular function.
The coefficient, right. The coefficients of a, well, how can you
Particular
determine the coefficients of a Fourier series so that you can get the total series, right now?
Yes, ma'am. Yes.
So what are the coefficients, Irfan?
मैम वो तो ऊपर पेज
A0?
में था, वो याद नहीं हुआ।
A0?
A0 मैम वो लर्न नहीं किए अभी।
Just
याद
now
हो
I
जाएगा।
have told. A0?
Yes, ma'am.
Anybody else? A0?
A and BN.
A and BN. Very unfortunate, Irfan. Now come to waveform symmetry. Some waveform does not have cosine terms, definitely, when an equals to 0. While some of them does not have sine terms when bn equals to 0. When you will do the problem, it will be clear. Ma'am, why you are just telling me cosine terms not an equals to 0? The terms associated with that will be equal to 0. Hence, it is called that cosine terms are 0. Also, in some other waveforms, the even harmonics of cosine terms are found missing. So this is because of certain types of symmetry associated with the waveforms, right? Which results in some Fourier coefficients being absent from the series. So on the basis of this theory, you will be able to tell that what are the coefficients of Fourier coefficients are absent in that series. So there will be no, I mean, you are not bound to do all the coefficients to determine, right? If you can recognize such symmetries, a considerable amount of labor may be saved, right? In the Fourier series analysis. The সবই আমাকে বের করতে হবে, not like that. If you know the basic trick, then you will be able to determine which coefficient is have to determine or not. দেখা গেল n বার করলাম, দেখা গেল ওটা 0 হলো। তাহলে যদি তুমি আগে থেকে, if you know that it will be 0, then no need to determine that, right now. So in waveform synthesis, we can see that sum of even functions that is equal to even function. Sum of odd function that is equal to odd function. Before that, you have to know what is even or what is odd function. However, if an odd function is added to an odd function, the resultant is neither even nor odd. The new function ft may be said to have an even and an odd part. So ft equal to f0t plus fet. 0 means, O means odd, E means even. Where fet that is equal to even ft, and this means odd of ft part. If put t equal to minus t, f of minus t, in case of odd, what will happen? From this equation, anybody can tell me? In case of odd, f of minus t equal to minus or same?
Minus, ma'am.
Even a ক্ষেত্রে কি হচ্ছে, in this case, e of minus t that is equal to this. There is no change. So in even function, that will be same. Right now, John? And in case of f
Yes, ma'am.
odd,
There will be a minus.
Minus, right? So f even that is equal to ft plus f of minus t by 2, and f odd half ft minus f minus t by 2. So what is even function? Again, I am elaborately telling you, a function fx is said to be even if fx equal to f of minus x. So what are the example of this? X square, cos x, tan x square, 1 plus 2x square plus 4x to the power 4. This is the example of even function. And what is the basic idea? F of x that will be equal to f of minus x. Now the cosine is an even function, as it can be expressed as a sum of constant and even function. Do you know the series of cosine? Cos is equal to 1 minus x square by 2 plus x to the power 4 by 4 minus x to the power 6 by 6. So all these are even functions. This is fx. Actually this will be shifted. It displaced. It will be shifted here. And this is right. And this is another even function. Therefore symmetrically distributed, right? Now come to odd functions. Obviously, it will be reverse of even functions. F of x that will be equal to minus f of minus x, right? So examples of odd functions will be x to the power 3 sin x, x cos 10x, whatever. The sine is equal to the series is like this: x minus x to the power 3 by 3 factorial plus x to the power 5 by 5 factorial minus x to the power 7 by 7 factorial. Obviously, sin x is an odd function because sin of x, that will be minus sin of minus x, right? Now come to the problem. Okay, Irfan, come to this problem. Okay, find the Fourier series expansion of the periodic rectangular wave.
Okay, ma'am.
Okay, just minutely follow this example. Each and everybody will follow, not only Irfan. So, আগে তোমরা পিকচারটা, this picture, I mean this waveformটাকে আগে তোমরা মাইন্ডলি নোটিস করো। এটা কি হয়েছে আমার 0 পয়েন্টে what is the value 1, right না? So minus t by 4 t by 4. Then after minus t by 4 the value is 0 and after plus t by 4 the value is 0. So within that period, at the point 0 the value is maximum, that is 1. This is periodic wave. This is not triangular wave. I don't know. And after solution, this you will get it. Now come to the solution. So the function ft is even, hence only cosine terms are present. Basically, mind it, if you determine here to get the Fourier series, what are the parameters you have to determine? Is
0 and n.
n bn. এবার তুমি কি করবে? What is n? n equal to this by this and that's equal to this and you will do this. What is bn? That's equal to this. So in that case, so what is bn? Do you remember how can you determine a0? 1 by t minus t by 2 plus t by 2 ft dt. Now আগে ফাংশনটাকে ডিফাইন করতে হবে, after that you will be able to do the solution. But bn equals to 0 তুমি previously বলে ফেলছো, because on the basis of this waveform symmetry you are able to tell that bn equals to 0. But if you do the calculation, you will be able that to say that bn equal to 0 and you will get bn equal to 0. But on the waveform symmetry, if you say that bn equals to 0, then there is no lever to determine bn equal to 0 on the basis of the formula. Did you understand কি বলতে চাইলাম?
Yes, ma'am.
আমি আলাদা করে আর bn বের করব না, আমি তো bn 0 বুঝেই গেছি। So initially you define the function ft equal to 0. So what is ft equal to 0? T less than minus t by 2 and less than minus t by 4. In this region ft equal to 0. Where ft equals to 1? T greater than minus t by 4, yes, and less than t by 4. In this period ft equal to 1, I have written over here. And again ft equal to 0, t by 4 less than t and less than, I am greater than t and less than capital T by 2. In this region, again the function will be 0. This is the function criteria over particular region where you will get 0 or 1. Now by definition, a0 equals to 1 by t minus t by 2 ft dt. So ft equal to 1 in this region where minus t by 4 2 plus t by 4. So you are getting half. The a0 বেরিয়ে গেল. Now come to an, 2 by t minus t by 2 ft cos n omega t dt, because are in case of bn sin n omega t dt. Do you remember? So ft equal to what? Ft equal to 1, right now? Now put the limit minus t by 4 to t by 4. In that region ft equal to 1. So 1 into cos n omega t, and again do the integration 1 by n omega into sin. Now put the limit minus t by 4 to plus t by 4. Then you are getting this n, that will be equal to 2 by n pi. For n equals to 159 and n equals to 246, an equals to 0 and 3711, that will be equal to minus 2 by n pi. You will do yourself, then you will be able to explain how can you get it. Now put the value. So ft equal to what? a0 an into that plus bn into that. That is the series. Do you remember the series? What was the series?
A0
A0 an cos n omega t summation
plus
of that plus bn sin n. This is the series. So come here. An cos n omega t. Okay, but you have to just pick up the value when cos omega t equal to z. The an part is 0 or not. That for 246 it is 0. So that part is not present over here. 2 by n pi 159. In that case, that will be present and that will be plus. And 3 7 11. Therefore, in case of 3, this is minus. Right now?
Yes, ma'am.
So this is the ultimate series, half plus 2 by pi n equals to 1 to infinity. And if you want to generalize the formula, minus 1 to n minus 1, 1 by 2n minus 1 cos 2n minus 1 of 2. This is the ultimate series. And just I have written over here, how can you get the value sin n omega t? I mean integration of cos n omega t minus t by 4 to t by 4. এটা কেমন করে তুমি পেলে সেটা আমি করেছি 2 by n pi sin n pi by 2. Okay. Now this is all this for today. Well, basically, what do you come to know today regarding Fourier analysis? পূর্বিতা বলো কি পড়লাম আজকে? পূর্বিতা,
Ma'am, first,
yes.
ma'am, first we have studied what is Fourier series, then its coefficients, that is A0, An, Bn, then how to determine A0, An, Bn, then harmonics.
And the conditions?
And yes, ma'am, their conditions.
Dirichlet's conditions are there. Okay. And ultimately, we have solved the problem.
Of numerical problem, yes, ma'am.
On the basis of that problem, we are able to determine A0, An, Bn. But before that, waveform symmetry and odd function is even functions we have studied, right? Yes?
Yes, ma'am.
Okay, that's all for today.
Yes,
Thank you
ma'am.
so much.